Hi guys, welcome back to my channel. So in this video we will go over this Green's theorem's problem. So it says to use Green's theorem to evaluate the line integral. So we have a simple closed curve given to us, and we have the boundary given to us which is x equals to 0, and an equation of a circle with radius 1 and x greater than equal to 0. Okay, so I hope you guys remember the formula for the Green's theorem. So the formula for Green's theorem is simply the double integral, and then we have qx minus py dA. Okay, so this is the formula for Green's theorem, and here the p corresponds to the I hat, the I component, and the q corresponds to the j component. Okay, so here this one is then our p, and then this one is our q. Alright, so here, so this qx basically means the partial derivative of q with respect to x, and here this means partial derivative of p with respect to y. Okay, so this is what it basically means over here. So what we're basically doing here is this calculating this q, and then doing the partial derivative of q with respect to x. Okay, so if we do this, we get 2x, okay, because we're only taking the derivative with respect to x, and there's no y over here, so only 2y. Okay, and then negative py, so the partial derivative of this one with respect to y, so we're only integrating y, and x remains the constant, and the derivative of y, it's a 1. Okay, so then we have this, so 2x minus x, which gives us x. Okay, and then we have dA. Okay, so now once we have this, what do we do next is, like, we need to know the limits of the integration, right? And here, so for this, first we need to draw this region that it's given with the boundaries. Okay, so let's go ahead and draw this region. Okay, so this is an equation of a circle, okay, with radius equals to 1, because an equation of a circle is x squared y squared equals to r squared. Okay, and here r squared equals to 1, so that means the radius we have is 1. So this is our region then. Okay, it's just a radius, just a circle with radius 1, but then we have x equals to 0 as well. So x equals to 0 is simply this line that you see over here. Okay, so I don't know if you can see it. I can use another color, maybe red. Okay, so this line that you see over here, this is x equals to 0. Okay, and here it says x greater than equals to 0. Okay, so that means all the x's that are positive. Okay, we're not taking any negative x's. Okay, so that means our region is everything that is after this, so all this thing cancels out. Okay, so wait. Okay, so everything that is inside this, so all the positive x's, we do not have any negative x's. Okay, so if we go ahead and draw the region neatly, so this is how your region should look like. Okay, so this is your region, this like half circle over here, and now we can go ahead and put the limits of integration. And since it involves circle, and every time you have circle, remember we use polar coordinates. Okay, because if you don't use polar coordinates, then you're gonna have to like isolate the x and y, and then you will have like square roots of something, and then it's gonna be really hard to integrate that because there's like huge substitution and all, so it's gonna make your life really complicated. So the easiest way every time you have circles is use polar. Okay, so let's go ahead and convert this equation into polar coordinates. So for polar, remember x is equals to r cosine theta, y is equals to r sine theta, and dA is always equals to r dr d theta. Always remember this r, don't forget this r. Okay, so here we can replace this x with r cosine theta. Okay, so r cosine theta, and then this dA with r dr d theta. Okay, so we are simply multiplying this whole equation with another r, and then we have dr d theta. This is how we're gonna integrate it. So this means this has to be r something because this is dr. Okay, and these limits has to be theta something. All right, so what do we do here? Then we try to figure out the r. Okay, so the r is simple, it's simply the radius. Okay, the radius of the circle, and so it's starting from r equals to 0 and going from r equals to 1, which is the radius of our circle. So it's simply from 0 to 1. Okay, and for the angle here, okay, angle is a bit complicated over here, but not that much. Okay, so for angle I can use what color? Pink. Okay, so here angle, you always go in the counterclockwise direction. Okay, so here if you go in the counterclockwise direction, like starting from here at the 0, so you see this is 90 degrees. Okay, and you also have an angle over here, so this is like the upper limit, and you also have the lower limit over here. Here, okay, so you have 270 degrees. Okay, so you have like 90 degrees and then you have 270 degrees. So 90 degrees in radians, so you always write the angles in radians because you're using polar coordinates. So okay, so the 90 degrees in radians, it's pi over 2, and 270, it's gonna be 3 pi over 2. So you can choose to write this in 270 degrees, or if you want, you can go in the clockwise direction, but in that case our angle would be negative. Okay, so if you go in the clockwise direction, so then this is 90 degrees as well, but it's gonna be negative 90. So negative 90 means negative pi over 2. Okay, and if you don't know how to convert it from degrees to radian, it's very simple. You simply do like 90 degrees and then you just multiply it by pi over 180 degrees. Okay, so then it's pi over 2. Okay, so it's as simple as this. Okay, so here what you can write over here is that here for the lower limit you can write negative pi over 2 to pi over 2, which is like positive 90, or you can write here 3 pi over 2. So either way, like if you choose to write 3 pi over 2 or negative pi over 2, it should give you the exactly same answer, so don't worry. So we're gonna go ahead and choose negative pi over 2. Okay, so let's go ahead and solve this. So now you can multiply this r, so you have r cosine squared dr d theta, and then you have from r equals to 0 to r equals to 1, and then you have from theta equals to negative pi over 2 to theta equals to pi over 2. Okay, so once you have written this, you can separate the r's and the theta. Okay, so here if we go ahead and separate this, so we are left with r squared. We're left with r squared dr, r equals to 0 to r equals to 1, and then we have negative pi over 2 to pi over 2, and we can, so we just separated the r squared and the theta because in the case of double integrals we can go ahead and separate it, and then afterwards whatever we get as the answer we can multiply this. Okay, so this one is easier, so let's go ahead and solve this one first. So if we're taking the integral, it's simply like adding 1 to it and then dividing by the exponent, right? So evaluating from 1 to 0, so this means for here we get 1 over 3 as the answer. Okay, but we're not done yet, we also have to finish this part. Okay, so the integral of cosine theta, it's simply sine theta, remember, and we're evaluating from pi over 2 to negative pi over 2. Okay, so then we're gonna write sine pi over 2 negative sine negative pi over 2. This is 1, this is negative 1, so this is negative 1. Okay, so then it becomes positive 1, which means 2. We get 2 over here, and now we can go ahead and multiply these two results. So if we go ahead and multiply these two, we get 2 over 3 as the final answer. And thanks for watching. Bye.